thing actually doing what we think it's doing? So how could we set up an experiment to find out, is this thing doing what it's actually supposed to be doing? Is it really listening to your brain? Well, that's why we're doing. Okay. So what are the two elements here? Right, independent variable and dependent variable. So what is our measurement? What's our behavioral measure that we have with this thing? Okay, we can measure the frequency, but we don't have the ability to analyze the parameters of frequencies across people. I don't have that technology. I do, but I don't know how to use it. Reaction? This will help. Yeah, so we looked at the rotation and movement of the cube. Is that an objective empirical measurement? Yes. Everybody can see when it rotates. Everybody can see when it moves. He was able to get it to rotate. Was he looking at it? No. So one independent variable was looking. Why is that important? Well, what if he's actually turning his head to make it turn like he's moving the mouse? If he's looking at it and knows what it's doing, then he could turn his head and it would turn. He moves his head up and down, it would come closer. Because it does have a little motion sensor in it like a phone does. So we had to rule out whether the motion sensor was causing the little cube to spin or move. So I'm going to write move here. So one of the ways, how can we test this? How do we test whether looking at it? That's the one independent variable. Yeah.
You have one party quadratic.
Right. So we blind one set of subjects. What's another way that we can do it? Well, yeah, that's the looking versus blind. Blind is the control. Looking is the experimental group. Okay? And it turns out, did he do just as well looking at it as he did not looking at it? Yes. So even though we trained something different, he did just fine both times. So that's pretty cool. Okay, so is the thing dealing with what your head's moving around? No, because when he's not looking at it, he doesn't know exactly what it's doing, so he can't move his head to make it do what it's doing. Okay, what's another thing? There's no real sound. Well, I mean, I can tell him things, but that's not, having him not tell him things, just let him do nothing. That's what you kept it. So, is it actually measuring brainwave? Hey, it's a terrible subject. Well, we have to have brainwaves. So, is it actually measuring the brainwaves of the movement, the premotor cortex, like it's supposed to? Well, you say that because you've seen it, but so this is how we tested it. The experimental group was told to move objects. The control group was told to think of a particular color. When you perceive color, that's back here. Color areas are right next to auditory areas in your brain. Auditory are here, color is here. That's why Neil's able to connect color and sound so easily, because the parts of the brain are right next to each other. It's like smell and taste. They go to the same part of the brain. When you smell and taste something, it's called flavor, and that goes into that part of your brain called the instinct side. Okay, so if I have students try to move an object versus try to think of a particular color, if it's not measuring a specific set of brain waves, what should happen? They should both move the thing. But it turns out only thinking about moving the thing moved the thing. That made us more impressed. Two subjects we had, one of them Tisha and the other one Melissa. Melissa had really thick hair. You hear him like soap and singing by the time he's finished. Anyway, but by the time they sat down, they were both given sheets of paper to look at a particular color, not looking at the screen. So I had it on my laptop, they couldn't see it up on the screen. And so they looked at the color, and then when they closed their eyes, okay, I want you to think of the color blue, think of that blue piece of paper, think of the red piece of paper, when you talk about the colors. The cube did not move at all. But when we had, I've done this lots of times, think about turning something, think about pulling something, and what happens? It moves. So we know that it's moving. Does it matter what you say? So if I think push or pull, does it matter? It actually doesn't. So I can tell you to think about standing on one foot. Stand on one foot, stand on one foot, and the cube starts to rotate. Because how do we get it to work? Not thinking about it. I train it. When this motor pattern is produced, this behavior on the computer is produced. So I had to train each one. And that's why I screwed up initially. When I redid it, I wanted to have him spinning it first and then pull it as it's spinning. But I clicked the wrong thing. So it didn't train it backwards. And so it doesn't matter. If I think push, 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 and I train the cube to think, oh, that push equals draw toward me, the computer doesn't know the difference between push and pull. It's just recording movement activity. A certain pattern of movement activity equals computer do this. Does that make sense? So these are a series of experiments that we've done with this thing so far. What's really cool is that if you're sitting down, we did one last semester where we had people listening to different music. And if the people liked the particular music they're listening to, what happened? Their brain produced more alpha waves. So we say they were calmer because their brain produced more alpha waves. But why do we say they're calmer even though I say their brain produced more alpha waves? Well, no. We can see their brain producing more alpha waves. Does that mean that they're actually calmer? Not necessarily. Because brain waves don't equal behavior. Brain waves don't equal behavior. Okay, so let me go back to this little test here. Let me close the test bench. Yeah, it's called the Epoch Emotive. There's a really cool TED Talk. Oh, I already did close it. Okay, there's a really cool TED Talk about them training somebody from the audience to do this in just a couple of seconds. Did it take very long to do that? No. And it's really cool. You can actually do more stuff than they did on the TED Talk. That's why I really like this thing, because the new ones, the one that I'm writing a grant to get some, there's a new one that's only got 7 channels, and then they're closed electrodes. So they're just really thin rubber electrodes, so you don't have to worry about the felt and the saline. You just stick it on the person's head and wiggle it around, and it goes to their scalp, and then the rubber conducts the electricity. Yeah. Now that TED Talk where you control somebody else's arm with your own arm, you can do that if anybody has a muscle stimulator. I'm ready to go to the physical therapy, and get the electrode stuck on you. Yeah, and it causes the muscles to tense up. So in our biolab, if I flex my muscle, the electrical current from my muscle can go to that other thing, and it's one little relay, and you just stick it in. It's really not that exciting. When I saw that, I'm like, you're not really controlling your muscle. You're just flexing a muscle, and the current's going over here with a resistor, an amplifier, and it's going to that person's muscle. They're flexing their muscle. Human centipede. No, I was kidding. Now, so what is the experiment that I ask you to do? They'll tie together in just a few seconds here. With the bicycle. It's called priming. Okay? Put the survey up here. If you didn't do this, it's fine. Don't care. why do I have to have this first thing? Whenever you're doing research that you want to ever try and publish, you cannot coerce people to do your experiment. As a faculty member, I have power and authority. I can coerce you to do experiments. Hey, as part of your grade, you have to participate and do experiments. So all I have to do is put this little statement there. I don't want to take the survey. And then you can still get credit for taking it if you were doing this for credit. My normal semester class has to do experiments for credit. But then this little thing, it's really important that you don't force anybody to do experiments. You can't trick anybody during experiments. You can't cause harm to anybody during experiments. That's why it says there are no graphic images. We did an experiment on disgust, which is we might do in here, so I'm not going to spoil it for you, but one of it, we're trying to find disgusting pictures to disgust people with. And don't ever type disgusting photos in Google. It's PTSD just waiting to happen. Just, yeah.
I thought it said you could receive them if you do something.
Well, as long as it's not going to hurt them. Yeah, you don't have to tell them everything that you're studying, but you can't purposely deceive them. You can't say, hey, if you click here, you'll get $100 by filling out this survey and being 1 out of 10,000 people likely to get $100. That's unethical. You don't want to force people to do experiments. Because if you force someone to do an experiment, the results don't work, they're not genuine. Anyway, so this was from Channel 8. So here is my independent variable. Okay, so I am giving you a prime. What is a prime? It's a stimulus. Yeah. To fool you, ladies and gentlemen, to show you that you too will be fooled when presented this way. A prime is something where you want to change someone's behavior next. We'll explain how they work a lot next week. They work through something called classical conditioning. But these primes are everywhere. Why do we have primes? Why do our brains tell us, oh, look at this. Where's the priming involved with here? Well, okay, so the question is who is at fault? So that's the initial thing, is we're looking for blame here. That's what the whole point of this experiment is to look at who's at fault. And so immediately you say, teen on fixed seat bike seriously injured in crash. Now, that title is, well, the title says teen on fixed seat bike killed in crash, or injured in crash, sorry. But there's a couple words in here. If you just look at this and then move on, where was the accident? Well, crosswalk. Okay, and so you see, oh, crosswalk. And then a teen, you think of some poor kid riding his bike to school and with a little basket and his little backpack and his teenage Ninja Turtle helmet. And so what the prime is the cues, and write the word cue here, are the stimulus. Are the stimulus in here? What affects, after just looking at this picture, what affects how you, an individual, rate this? Well, that's what you just said, it's the car's fault. But how do you come to that conclusion? Okay, maybe the crosswalk. Pedestrians always have the right of way. Yeah, the car definitely is cattywampus in the street. It's definitely not straight. So there's a lot of cues that are in here, especially as a cyclist. Never ride in a crosswalk. You act like a car. If you're going in a crosswalk, people on bird scooters are hitting crosswalks constantly.
The other day on the LA T-shirt, we were going crossing, I hit, and the guy went on like a floor highway troops that all the.
Woohoo! Love those. Is the person killed on the scooter?
No,
Okay.
they're alive.
Perfect. Then it's okay. My friend was a CHP officer for years. He just retired, but he's like, I speed chase. Oh yes! And he'd like let him go for a little while so he could get some chase. He during the CHP driving course, you have to pass a driving test. He actually, on his first try, was like 3 minutes ahead of where he needed to be to pass. He jammed on the brakes and waited so he gets to do it again. Anyway, he's psychotic. Retired psychotic. So I'm going to put learning. And I'm going to draw this up here. Your little wheelie suitcases, your biases. So this experiment right here, this picture right here is full of biases. It's full of biases. If you are a cyclist, you might feel different about this. If you know what a fixie is, you might feel different about this. There's a lot of things. I had a student from Costa Rica, and she goes, well, the bicyclist shouldn't be riding on the road. Did anybody been to Costa Rica in here? The roads are pretty much one-lane roads pretty much everywhere. And big trucks drive down them. Cars going both ways. There's no shoulder. So if you're riding a cyclist, what are you? Or if you're riding a bike on the street, what are you? Stupid or crazy? They have a triathlon club. My friend spent a couple months down there. The triathlon club, she goes, where do you guys ride? Well, there's one road that goes around a lake that they can ride on, and most of them train indoors. Because the truck goes by and there's one lane. And the truck, is it going to pull over for you? It can't because there's one lane. Sometimes they'll slow down. Sometimes. How do you get a driver's license in Costa Rica? You can reach the pedals. Moving on. Okay. We have students in the Middle East. Who rides bicycles in the Middle East? Depending on where you are. Depending on where you are. Say again? Yeah, you don't see, and generally people doing something stupid. Especially if it's in the middle of the summer. You see anybody riding a bicycle? Like, what are you, stupid? Anyway, so depending on where you are, where you come from, the culture you come from, you could perceive this as being different. In some places, only poor people ride bicycles. In some places, poor people are considered stupid because they're poor. That's brilliant. Okay, moving on. So what are these then? These are my dependent variables. Variables. I ask a bunch of questions. We ask the bike is at fault, the car is at fault, and who should be more careful. So basically, projecting onto the subject. These are nice, these are what we call Likert scales. The scales are cool because I can count these and add them up. Because they're all on a scale of 10, I can recode them. Take a research methods course, you'd find lots of excitement about this. But I ask the same set of questions. Then I show you the video. Oops, sorry. Get back. So what's the video about? Extreme fixed gear. We used to do these in college. I'm too old for this now, but we come point-to-point races, or they used to call beer races when we were in college. But what you basically do is at San Diego State, we start on the bus circle, and then one of the people who's organizing it says, Ocean Beach Pier. Go. And what do? The first person to Ocean Beach Pier wins, gets a 12-pack of beer, which pretty much is then split up amongst the people who make it there first, and then they all wobble their way home. It's pretty much standard college fare. But, so, I mean, one time we were doing it, we were going down Friars, drafting behind the 80 bus. Going 45 miles an hour down Friars Road, drafting behind the bus. Do these bikes have brakes? No, if you pedal faster, you go faster. If you pedal slower, you go slower. They're fixed gear. And so it's, yeah, I mean, so I used to ride my mountain bike because I didn't have a fixie. But I rode a fixie for about 15 or 20 years, and I just don't ride on the roads because my friend was killed. But are they being safe on their bicycles? No. That's called salmoning up when you ride up. I don't understand that either. I think it's just for making movies. But these guys are really notorious in New York. They're bike messengers because they can get packages delivered across the city way faster than cars can. But they don't really care. Thunk. Okay? And so, all of a sudden, what does it change with this little word right here? You might think, oh, wait a second. The cyclist was being an asshole. Yeah, and that's what the whole point of the prime is that if you understand fixie culture, you read that differently. I rode on the streets for a long time without brakes because it really makes you a better cyclist. Because you have to pay attention, not to what's going on now, but what's going to happen next. We can't. Anybody ever live in Fletcher Hills? You know why it's called Fletcher Hills? Yeah. I didn't realize that some of the hills were so steep. So I went up there, I was on my fixie, and I came down the backside toward Santee. I don't know, it's the one you go up by the church, and then you go around this way, and then you come back down, and it was insanely steep, and I'm on my fixed gear bike, and I'm like tacking and like trying to slow down, and going back and forth, trying to not go too fast. Because once you get up to a certain speed, you can't slow down, and then your knees spontaneously explode, and then you get covered with road rash, and your friends laugh at you. Good times. Okay, or worst, your chain comes off. No, you can't break it off. Or no, you stick your foot between that BMX style. You ruin your rear tire. Anyway, I'm too much of a pansy. I'm not into that. So then I asked the next prime. Anybody remember when this would happen? This is the woman that went the wrong way on Fiesta Island and smashed into the group of cyclists. And then was yelling at the guy on the ground for riding in the middle of the street. She was on amphetamines and under the influence of alcohol during the crash. And so when this was first prevalent, when I put this up here, that was much closer to the time when she actually did this. And so people recognized the news story already. And so people go, oh. But if you've forgotten, if you didn't have heard about that, then that prime fades away. But all of a sudden, a DUI suspect who hit cyclists, does that change your opinion of what happened again? Yeah, because as soon as the object is to look at the change in the way that you answer these questions. Okay, so we can actually just see this. We go back to the form. And I'm not going to do the statistical analysis on here. Yeah, I've done this a couple semesters, so I just want to go. I didn't mean to open that, sorry. Well, it's just for your fun, if you care. So what it does is the Google form puts out a big spreadsheet. And the Google form generates data. So it puts it out into a giant Excel spreadsheet. We're going to zoom here. But you can see that all those questions are answered. I can dump this into a statistical software program and do analysis really quickly. It's pretty cool. But we can just also look at it with the Google Analytics. So what we're looking at is for parameters. We're looking for parameters. What did most people say? 23% versus 26% people thought halfway. Bicycles at fault, bicycles doing something. Half of them thought, I don't know. But almost the second highest percentage is no, the bicyclist wasn't doing something wrong. Yeah, so we would recode this as 1 through 3, 4 through 6, 7 through 10. Stats. Car was doing something wrong. Most people said yes. Now, how come it's not perfect? everybody has a slightly different perspective and everybody has a slightly different learning history. Okay, so that's what our statistics are for, but we're looking at this. The person on the bicycle should be more careful. Everybody said yes. Not everybody, but the majority. So we're looking at parameters. We're looking at estimations. Person in the car should be more careful. Nobody said no. That's nice. I like that. The bike should be held responsible. What do you notice? There's much of the stronger leaning toward the middle, but the leaning for the middle was at the first one. But look at this. That wasn't there before for who's at fault. But this is also still there. So this is there, but that changes. Okay, so we look down. Okay, so now the person in the car should be held responsible. Majority of the people thought the person in the car should be held responsible. From 5 to up. Very few people said no. After watching the video, did the prime change the way people answered the question? Yes. Okay, and this is without any statistics, just looking at it. The driver was doing something wrong. All of a sudden, did it change? Just by the way the information is presented, it changes your behavioral response to those questions. Person on the bicycle should be more careful. Same. People on bikes should be more careful. The person in the car should be more careful. Notice it. It's spread out more. The person on the bike should be held responsible. Complete shift from what it was before. And the car, it's pretty almost evenly split across the whole thing. Okay, DUI. What do you notice? Well, look at this. I don't care if the lady was drunk. That cyclist is crazy. So what if we did this experiment again with another class, and I present the DUI first, then the fixie? Do you think that would change the results? Yeah. So what's happening here? Okay, so this is actually the real experiment. That's the whole point of the experiment. Depending on how I prime you one direction, which is very severe, and then prime you the opposite way very subtly. What is a stronger effect? The fixie riders being cray-cray affects you more than the lady being drunk. Because if you look at this graph, even though the lady's drunk, they thought the bike was doing something wrong. Now, we haven't got to who's at fault yet, but the priming, this is why when you have a news station that talks about immigrants as invaders, they're invading, they're terrorists, they show M316, whatever the gang is, MS something, whatever. They show whatever vicious, gnarly gang members, and they say, yes, here are the immigrants, versus our neighbors who are immigrants, who are a very nice family. And Lupe's this tall. Not exactly MS-13. But at the same time, it's when you see the pictures, depending on what news station you put on, depending on what you see, versus, you see on some news stations, they see everybody from Iraq's wearing a turban and shouting, screaming. They even wear turbans, doesn't matter. Versus if you actually go to Cuyamaca College and you meet lots of people from Iraq, what do you notice? They are. They're very similar to everybody else. In fact, if you meet everybody, they're very similar to everybody else. But why do people change opinions? Well, it's their biases. It's their own internal biases. And that's the whole point about what the whole psychology is. And then we look at the driver do people agree the driver was doing something wrong? Yeah. But the cyclist was also doing something wrong. Who should be more careful? Bicyclist? Both. The person on the bike should be held responsible. It looks like the prime. Car should be held responsible. Looks like the first one. But most people said yes, the bicycle. Okay, so now this was the other part of the experiment that one of my students was working on as their final project, is that we broke them apart by culture to find out if different cultures change their responses differently. And we did find that Middle Eastern students, we took Chaldean and other Middle Eastern and combined them into one. And we found out that those students found the bicyclist more at fault, the car less at fault overall. And so that's when we started talking, well, so we make an observation with an experiment. So we started talking to some of the students in my intro class and said, oh yeah, a lot of the people that ride bicycles where they came from were irresponsible. So what did they immediately assume? The bicyclists are irresponsible. And as a cyclist, it was really interesting because I always assume that the car is at fault. But I've seen people on bikes do very stupid things. And I always hate it when I see bicyclists doing stupid things because it reflects on me. Like, hey, I thought an old lady crashed over by Mission Valley yesterday. 2 or 3 people were helping her, so I didn't stop. But I felt really bad. Just an old lady just tipped over on her bike. I was like, oh. Because when you're old, you tip over. You break stuff. Yeah, that's why I don't ride the Fixie very much. Okay. I'm actually going to start riding it soon. Whew. So, how many people figured this out? How many people got it? Raise your hand if you think you've got it right. Did you figure out the experiment? So let's go through the questions and see how you answered them. Okay. What's being manipulated? What's being manipulated is the prime. So when you say limited information, what do you mean? Right. Okay. So that's right. That's exactly that is the prime. The situation without the context and adding more information as you go. That is the independent gradient. And that's exactly what we're trying to test. In other words, we manipulated the amount of information that you have been getting from this accident. Okay? What is being measured? Your behavior reaction. 0 to 10. Now, literally the behavior is this. What button you fill in and click. But again, is that a behavior?
Yeah.
Yes, because in order to do it, you have to click. You have to move and click. Is it objective and is it empirical? Yes, I can see what you click. I can click on each person and see what answer you gave for each one if I really wanted to spend that much time figuring that out. Okay? And so it's nice because is it a grade dependent variable? No. No, but it's all we got in surveys. It's what works. Okay. What's wrong with this experiment? Yeah, so it's limited information. Okay, I'm going to write a word up here that goes with bias. And these are called confound. A confound in an experiment is what you didn't think of. So some things that you didn't think of. So what else is wrong with the experiment? Not knowing enough information. That was kind of a part of the experiment, so that's not really a problem with it. That was the point of it. But yes, that's exactly, yes it is, so perfect, yeah.
Well, not every fix is either extreme.
So what would be, how could we fix, pardon the pun, that? Right, so maybe we could set up a second group of subjects and show them stuff like, well, there's not fixie riders, but let's do this guy. Okay, so we could show somebody riding the hour record. This is a really great video. It's only 3 minutes. This is a guy riding a fixie. That's what track cycling is like. So the goal in that race is to see how far you can go in 1 hour. My best is 23 miles, and that was around Fiesta Island. These guys go 39 miles, I think is the record right now. Averaging 39 miles an hour for an hour on a bicycle. The recumbent ones you lay down with the little fairing on them, they've gone 58 miles in an hour. I really want to build one of those. Okay, sorry. Okay, so what else is wrong? Well, so how could I fix that? How could I control for that about cyclists, what you know about cyclists? So set up a separate experiment, show track cycling on fixies, and then have them answer the questions and not show them the part about the cray-cray fixies, and compare the two. Yeah. But see, the point of the experiment is to see the effect of the emotional prime, my job is not to explain the accident. My job is to manipulate your reactions to the experiment by the way that I present the information. Yeah. Simultaneously? Because we did give both sides of the story. Yeah, so what if I put the video of the fixie and the lady at the same time? That would be a different prime. Maybe it wouldn't have the carryover effect as if you only see one and answer the questions and then see the second one and answer the questions. So that's another good way to fix it. Okay? So whenever you're doing an experiment, we could start answering these questions. And every time any experiment's ever done, you start asking these questions. So what I really think about when you're doing experiments is that every experiment can always be made better. The problem is if you try to make it perfect, what happens? It defeats the purpose. Exactly what you said a few minutes ago, is that if you fix all these problems, you won't find results because the gaps in information are actually what we're really interested in studying. If you want to market, if you want to go into marketing, if you want to go into advertising, is this important kind of stuff to know? Yes, when all the candidates put out their political ads, what do they do first? Point out all the things that are wrong with their candidate and then tell you about the things that are good about them. Yeah, because what they do is they put the prime in your head of they're bad, and then they fill the prime back with I'm good. And the simpler the rhetoric and the more easy that they attack people's learning history by calling immigrants invaders. That language, if someone is saying, wow, they're invading our country, what are they going to picture of? Red dot. Wolverines! Oh, high school flashback. Okay? That's a horrible movie. I think I made about 3 minutes for stupid. No. But they think about an army, Canada, marching down. When we talk about let's go Canada! Okay. Now that I think about it, that's really depressing. Okay. But you think about armies marching across borders, taking over. But why use that rhetoric? To bias the way that someone answers the questions when they're asked later. That's it. And so priming is a really fun thing because we're going to show you how it works through the different schools of psychology. So we're going to take a little break here in a minute, but then we're going to put the different schools of psychology up and then see how priming can be explained through all the different types and different ways of studying psychology. And then, right near the end of class today, we're going to start talking about the brain. Because guess where priming primarily starts? In the brain. Could we see it just with him? Yes. Just by allowing you to start moving the mouse around, immediately you figured out how to move it around. We didn't bother to get the clicks going. I kind of forgot about that halfway through. But you can actually start to click. And could you actually click and then type? Yeah, because especially on this stupid thing, if I hit this little button, it should say something. Hi, Cortina. Oh, I don't think it's set up. Never mind. But I can talk to, oh, there it is. Hi, Cortina. Hello. You're stupid. I hate Windows.
Hi there.
I know. That's why Windows doesn't have it work. Hi, Google. Oh, quiet. Yeah. Hi, Google.
Hi, what can I do for you?
Google's got to figure it out. Windows. Have you met Siri?
Opening YouTube.
Hey guys, welcome to CES 2016. I'm not really sure where we're going right now, but we're here, we're on the floor. I'm also with my co-ambassador.
That's the voice of Siri.
Oh, they're everywhere.
That's the voice of Siri. Ah! So now I've met Siri. Yeah. That was weird. I love it. Okay, the internet's a cool place in darkness. Okay. So if I give you this on the test next Wednesday, could you do this? So I give you a prompt of an experiment, and you have to tell me what the independent variable is, or be what the dependent variable is. What's the easiest way to know the difference what independent and dependent is? Because we discussed this morning. Okay, careful saying the word change, because did our answers change? Did our dependent variable change? Yes. So it's not things that change, because it's change itself is a. So you can't say change. Change is not a good word. Let's not use change. Don't use change. Okay, good. Manipulate. What else were you going to say? Okay. Yeah, so manipulate it. Okay, so let's do another experiment that we worked on. This is actually 2 years ago. Do you need to lift heavy weights to get stronger? Not looking for an answer, looking for an experiment to test it. Everybody loves answering questions. Yes. No. Yeah. Okay. That's the hypothesis. That's the observation. Do you need to pick up heavy things in order to get strong? Okay, so in order to do that, to test that observation, what do you do first? Before you can have groups, before you can control anything, parameters. What are the parameters that I'm looking for? So I have to define first the parameters. So on that experiment, on the one that we just talked about, the parameters were 0 to 10. That was my parameters. Who was at fault? 0 to 10. The bicyclist was doing something wrong, the car was doing something. 0 to 10. It's an easy parameter. If it has a 1, it has a 10, we know that they're different. Right? So I'm using the word strong. So what is a parameter of strength? Okay, so lift. So, we're going to use science. We're not going to use pound. Use kilograms. We convert it to pounds so you understand. Okay, so stamina. Yeah, or in stamina or endurance. Okay. What else? Is there a standard measure of strength that we could use? I'll write this up here. Newton's is a measure of force. Yeah. Watts are time. So yeah, watts, power. But so Newton is the amount of force that someone can produce. If you measure, there's a spring scale that you can squeeze and measure how many pounds of force you can put out with your hands. There's all sorts of different potential ways of measuring strength. But why does, so stamina, what is a measurement, a parameter of stamina? Yeah, time. Well, just if I can, it's more than the answer to how fast. Okay, my theory, there's only a certain number of miles that you can run in your entire life. I ran out like 3 years ago. Oh, not miles. Darn it. Didn't get that treadmill warranty either. Okay. Hard enough. So stamina would be time. How many pull-ups can you do in a certain period of time? That would be a measure of strength. What's a problem with each measure of strength? Varies in a person. There's a stupid moron at my gym named Alex who can do like pull-ups all day. Remember making daddy toes? Yeah, that's Alex. Except Alex weighs about $130. And he's just this little skinny, scrawny guy who's super strong. So I did like 4 today, and I jumped in the last week. Hey, pull-ups. You weigh 240 pounds to do a pull-up sometimes. Makes my arms hurt holding above my head. Okay. But, so, in order to measure strength, because everybody's different, what do we have? How do we measure it? That's another question. We're still trying to measure how we're going to measure how strong you are. How do we know what your median is? Test it. We have everybody go. Let's see how many push-ups you can do. Yay! We need a crap ton of smoke, so I'm not doing it. But so we see how many push-ups you can do. Then, fill in the experiment, and then do the test. So as long as we have a good parameter, we're actually measuring the change delta strength. A change in strength, whenever you're having to try to measure, does something change something, you have to measure a change in. Wow. Heavy. Very fun. Okay. So what's the primary independent variable? Or what is it? Do you need to pick up heavy weights in order to get stronger? Yeah. So weightlifting. What are the two groups that we're going to use? Yeah, heavyweight workouts and lightweight workouts. Same period of time. And then what do we do? Test them again. So there's the way you assume something is heavy is you look at something called percent of mass. So percent of mass. So if you're doing heavy stuff, you're looking at 80 to 90% of your mass when you're working out. What would light then be considered? Yeah, 30 to 40% of mass. Okay? And so this is why a lot of weightlifters will max occasionally. We max twice a year at our gym. We want to see how much weight we can pick up. And so the goal is, once you have an idea of how much weight you can pick up, that's your test. And every year, twice a year, we test this. We also do the hour bicycle race once. My buddy Jim and I do it once or twice a year. Why do that? Just to have a benchmark. Every Friday for probably 10 years, my buddy Jim and I brought a bicycle scale with us to go biking, and we weigh ourselves either before or after the ride, depending on how fat we felt. If you're feeling fat, you weigh yourself after the ride, after you dehydrated yourself a bit. One time he lost 12 pounds on the ride. His camelback didn't stay properly. Anyway, so when but by maxing, then you can see what's happening with your strength. So you said age, but is age controlled for this by looking at your percentage of mass? No, because old people should be careful when picking up heavy things. Things break. Young people should be too, but you don't have to worry about it too much. Yeah, your BMI. Your BMI matters. Because I have I don't know if I'm grossly obese right now, but I'm definitely obese. My friends are obese, you're not morbid. But I weigh probably close to 240, 245 right now. It's not good, too much for me. But I'll get you on it. It's got to stop this. All I need people? Okay. So, but because I'm heavy, can I pick up bigger things? Yeah. So, okay, so, but now, so what do you think the answer to this is? Well, we have male, female, we can do different ages, we can do different athletic abilities. Because some people just aren't weightlifting kind of people. If you're not a weightlifting kind of person, are you going to struggle more, even doing the leg stuff? Yeah, so there's lots and lots of confounds. So the way we did this is over 3 years. 1 year I lifted very, very heavy all year, and then tested my maxes. And the next year I lifted light for an entire year and tested my maxes. And then I went back to lifting heavy again. And what happened? No change. Every year I got stronger. Oh. But there's a lot of CrossFitty folks that think that you need to pick up really heavy things occasionally. Why would you have to pick up something really heavy? to make sure that you're better than someone else. No. That's a CrossFit motto. As long as I win, it doesn't matter what happens. Turns out that when you really pick up something very heavy, you activate different muscle fibers than when you pick up light things. There's deep tissue fibers and small tissue fibers, and if you only pick up light things, those deep tissue fibers get weak. And so you have to activate the deep tissue fibers. Yeah. I don't know that much about it. I'm listening to the moron CrossFitty friends of mine. That all of them have injuries because of doing stupid things because of heavy. So I do stupid things by like jumping my bicycle and slipping in the mud. That's how I hurt myself. And not picking up heavy things. I did pull my butt, but that was annoying. For warming up for deadlift, I'm like, doink! Ooh, there it is. Technically a piriformis, not the full push, but still 6 months later, finally back. That was, yeah, don't get old, people. It still hurts if I run. Okay, so I don't run. Perfect. Okay, so whenever you set up if we were to try to do this experiment with just you, what would happen? Could we do this experiment? It would require so much effort to do this experiment, it wouldn't be worth it. In order to do this experiment with college students, you'd have to first get everyone tested medically to make sure that they're able to work out. That would cost a freaking fortune. The second thing is you'd have to find volunteers that are willing to stick with it for a period of time. So you'd have to pay them, which would cost a freaking fortune. Universities can do stuff like this. At San Diego State, Dr. Bono, I did a study of fat athletes, basically. Because I was a shot putter, I weighed about 280 pounds in college, no neck. He wanted to test us, the football linemen and a bunch of our big shot putters, compared to other athletes on our physiological fitness. And do you think a lot of big fat athletes like myself are physically fit? Yes. It's muscle mass. The problem is that carrying a large amount of muscle mass affects your heart differently. So someone who, even though I'm extremely fit at my height or my size, I have a lot higher risk of heart attack just because I'm carrying so much more mass. Well, skinny distance runner folks, no offense, skinny distance runner folks, their heart doesn't have to work nearly as hard as my heart. In my head, I'm one of these guys though. Riding my bike up the hill in Tour de France. That's me. Except I'm wheezing and sputtering and coughing and cussing the fact that I weigh 150 pounds more than he does. How much you weigh? Haha, 120 pounds more than you. Give an extra one of you. Dr. Thomas, I worked for a professor, Jennifer Thomas, that was about your size. She weighed about 15 though. And I was laughing because I'm like, I could lose you and still be healthy. She goes, you could never lose me. I'm like, yeah, whatever. She's the dean of graduate admissions right now at San Diego State. So, you want to get in state, let me know. I got some connections. Jennifer Thomas, she's wonderful. Yeah, she keeps laughing at me because she's like, how did you get your job? Like, I don't know. Because she wishes she didn't have to do all the crap that she does. Well, she really likes it. I'm purposely kind of starting this class a little bit slow. Okay, first of all, the one main reason is I was on the second, we didn't know if we'd be back from skiing or not. So I was just basically going to give you the assignment and I had a sub ready for me, but then we got back. So we're about a half a day ahead of where we were supposed to be so far, but it's kind of nice to start slow and then slowly speed up as you go. So we haven't covered a lot of information so far this class, but what I'm trying to do is I'm trying to get you set up so that as we start speeding up a little bit more, you have a good framework to try to talk about this idea of psychology, of what this whole class is about. So over the course of the next couple classes, we're going to be breaking down each one of the schools of psychology and expanding out on each school of psychology. So I wanted to do it today with this experiment with the priming, and then the next class, at the end of class, we'll start talking about the brain, and then as we go through and start talking about the brain, then we'll start talking about other factors that lead through. But we're going to use this experiment as a way to talk about it initially. You'll get tired of hearing about it, I'm sorry. My research methods students, when they work on an experiment, they start the experiment the third week of class, and they work on the same experiment all semester. Are they totally done with that experiment by the end of the semester? Yeah, they're so tired of looking at it. But does it take a long time to do good research? Yes, and it's boring and it's tedious and it's awesome. Okay, so what are the different schools of psych? Well, okay, so business psych. Hey, there's Kenny. Swipe up to answer, text reply. Write your own text. Sorry. Teaching. Okay. So what are the basic schools? They're right here, by the way. Okay, physiological. Physio. I'm going to write this. Behavioral. Okay, so I'm gonna put evolutionary up here, and psychodynamic, or psychoanalytic. Okay. What else? Okay, so now remember what this second slide is. Clinical psych and experimental psych are applications of the basic primary schools of psych. So these are the different basically these are the upper division classes that you take in psychology if you get a major in psych. And these are the ones, so you can go clinical or experimental, those are the applications of the basic schools of psych. Okay, so what's the checkbox for? Most people just want to pass and don't care. That's what the checkbox represents, which is fine. Okay, so I will make you care. No. So I like this fuchsia color, but it doesn't show up on the board. Okay. Make darker. Thanks, Kenny. Didn't get the message that I was teaching. Okay. He did, but then he texted back. Okay. So for a prime, when I give you a prime, when I start talking into, my microphone, okay, why do you assume it's a microphone? Because you're talking into it, and we can only hear you when you
when you're speaking, when he goes, I took the microphone off of the stand, you know how he stopped talking when he was doing that, he's very purposefully presenting sensation and perception. So in the brain, our primary function of our brain is to sense and perceive information. Sense and perceive. So our sensation and perception is in our brain. Could we easily see when he was looking and not looking on the brainwaves? Yes. By our primary sense of sensory input for humans is vision. Vision is our number one primary sense. I was very happy when I had my eyeballs lasered. But back in the old days, I used to wear glasses. I don't mind wearing glasses. I wear these all the time. But the problem is that when you get to a certain age, you need these kind of glasses as well as those kind of glasses. Do you have bifocals? Bifocals? So a bifocal lens is where you have a reading glass lens at the bottom and your normal lens at the top. And what's in between the two? You have bifocals? Yeah. Okay. Yes. Oh, look at those suckers. And so what's great about the bifocal lens is, well, it's nothing great about it. It's the most horrible thing ever invented. Because can you walk? No, it's really hard to drive. You're like doing this the whole time. And it's like, try to ride a bicycle sometime. I tried riding my bicycle without my glasses once. I hit a curb going 20 plus miles an hour on my fixed gear. I thought it was the little ramp coming up. I missed it by about this far. It was like one of those Tour de France crashes. The back goes over the front, blew the front rim broke into 3 pieces. Nice. Hardened aluminum. Awesomeness. Okay. So I'm very paranoid about my vision, and so it took me a long time to get my eyeballs lasered, but I like doing active things. It's really hard to be active with glasses. I mean, how many times have I just dropped these? Yes, it worked wonderfully. Yeah, it worked. They know what they're doing. Just go to some place that has been around for a long time. That's all I suggest. Yeah, eyeballs lasered, $49.95. I had 2 or 3 of my students go down to Mexico and have it done because they can do stuff that's new that hasn't been approved yet here. And don't go to a fly-by-night place, go to a reputable hospital, and you can get it done significantly cheaper. And they know what they're doing. But you also can put money away for it tax-free, and if you use it for medical expenses, you can take that 403B. I don't know. You can put money away out of a paycheck and then pay for your medical expenses without having to pay taxes on that said money. So you save a couple $100. I do it. That's what we do. Anyway, but why get my eyeballs fixed? Well, my eyeballs started rejecting contacts. If you've worn contacts for 20 plus years, your eyeballs eventually start to swell up when you put the contacts in them. The eyes are like classically conditioned to I don't like contacts, don't touch my eye, and they get puffy. That's what happened to my wife, and then she got her eyeballs fixed, and now it started happening to me, so I got my eyeballs fixed. But if you don't have clear vision, what happens to your attention? It decreases, it goes down. It becomes frustrating to try to concentrate if you have clouded vision. That's why if we put a smudge on one of his glasses, what happens? It's extremely distracting when your vision is slightly impaired on one side or the other. Even kids with an eye patch, is it extremely frustrating for a while if you have the lazy eye patch? Yeah, because you lose a part of the world, and it's very so. This visual sensation and perception is the window into our consciousness. It's the window into our mind. And that's where most priming occurs. It comes through your sensation and perception. If we block off sensation and perception, you're not affected by priming. Okay, so your brain has 100 billion neurons. Well, 86. Some lady counted. Okay, 86 billion neurons. And each little neuron sends electrical signals. That's what we're measuring from his brain. We were measuring all of them with his brain. All of them firing, all of them sending electrical signals. That's why when he moved, they all went nuts, because we're measuring the movement of his head and all the electrical activity in the muscles in his neck. If we wanted to measure each neuron individually, we would take a really thin wire and embed it into his skull and have that thin wire poke into one particular neuron. And we can actually measure a single neuron firing. I'll show you a video of that, either this class or next class. And it's really cool, but so what if you know what 1 out of 86 billion is doing? Does that help you? No. Because every single cell in your brain has its own job. Every single cell has its own job. Each cell is like a little person. They have their own job. They have their own feelings. They have their own frequencies. They have their own particular job. Has anybody ever seen these giant jellyfish live in the ocean? Okay? The ones that live in your swimming pool are just weird. Just ignore those. But these giant jellyfish, there's the purple ones that were floating around San Diego 2 years ago when the water was super, super warm. Yeah, it's something like there's not the Man of War, but there's some other one that, yeah, they come up to the surface and they have this big crest that they migrate with. Yeah, they're purple and they get caught in the surf and then they get smashed in little bits and then the tentacles come up and still sting you. Yeah. The best part is every single little cell in that jellyfish is its own little creature. Yeah, they all get together and form this giant thing. There's some that form these giant tubes. They look like giant worms, but they're all individual little creatures that just kind of stick together. And when they stick together, they go, okay, you bend your neck there. Okay, you bend your neck here. Okay, and then all of a sudden they keep bending their necks and eventually make this giant swimming thing. Weirdness. But your brain is kind of the same way. Every cell has its own little behavior, but each cell is connected to up to 10,000 other cells. And when one cell does something, it affects the cells downstream. So all the cells downstream are affected by a single cell's changing of behavior. Now, if just one cell causes a problem, does it cause a problem all the way down the chain? No, because there's 10,000 other ones that are also influencing it. And so each of the brain waves, the brain activity we see, are patterns of cells firing, not just individual neurons. Patterns of cells firing. So when we talk about the sensation and perception, it's patterns of cells firing. I'm going to write this up here. It's patterns of cells firing. So as we're going to talk about this a little bit later, in just a few, like 20 minutes here. We're going to talk about it in just a few minutes, but we're going to show you where different parts of the brain are, and where when the cells fire in that area, what happens with your sensation and perception. Well, we're going to show you that. Okay, so one other thing about priming. So what does priming do to the patterns of cells firing? I wouldn't say confuses it. I would say the exact opposite. So I understand what you mean by confusing it, but it actually organizes it. It tells you what you're going to do next. What the cells are going to do next. And so, like, see if I have this one in here. This one might have an extra string after that. Just in case you need an extra string. Okay, this is called an off-string yo-yo. Okay? So, an off-string yo-yo is not attached to the string. That's why it's called an off-string yo-yo. I'm not really good at this, so be careful with that. Oh my God. But so the off-string yo-yo is fun. I mean, you can still do yo-yo tricks with it. But is it a different thing than a regular yo-yo? So what do I have to do in order to play with it? I have to know what kind of yo-yo I have. Because if I throw it the way I'm throwing it this way and it's attached to the string, it'll go and hit me in the face. If I don't throw it up, you throw it out and then use your hand to kick the string so it goes up. For some reason I broke the other one I had. I don't know why. There's one that's really cool, that's expensive, it's rubber. And it's like this hard rubber, and it's really fun because you can like kick it and catch it. And that one was on sale when Toys R Us was going out of business, so I got it. gonna be sad, Toys R Us. Anyway, so as soon as I know if I grab any particular yo-yo out of there, do I know how to use that particular yo-yo? Yeah, it's like your old Duncan butterfly. Yeah. Okay, so as soon as I see that, I know how to use that because do I have a program of behavior associated with that sensation and perception? Yeah, so you actually develop programs. They're called motor programs. And these motor programs tell you how to act when a given situation is present. So you see the situation and you know how to act. I always love it. One of my students, Owen, who's a great psych major, he went up to Sonoma State, not Sonoma State, that was Jonathan, Humboldt, same idea. And he was living large, sending weird pictures on our campus, our Cuyamaca Instagram, so we blocked him. Anyway, but Owen was a Iraqi war vet, and he worked as a medic. And he had a lot of trauma from his being a medic, but we had a student, Thomas, pass out in class once. Poor Thomas you can see if someone's gonna pass out, they really turn green. If you're darker skinned, you turn pale, like gray. Pretty kind of fun, okay? But all of a sudden, Thomas is turning green, like green, like he's gonna throw up. He gets up and makes about 4 steps, completely passed out. So before I could even reach over to grab the security phone to call our CAPS folks to come over and help him out, Owen is like, ninja skill, jumped in, he has a trash can under his lid, under his head, and then a thing under his feet, and he's like, okay, and he's clearing the space around him. How did he go into like ninja mode? Training. He has a motor program. He knows what to do when someone passes out. He doesn't even have to think about it. What's interesting is his eyes got wide and he stopped paying attention to everything around him. Because is that motor program very well trained in him? Yeah, in fact, he kind of loses consciousness when he goes into his motor program. He's hyper-vigilant, hyper-focused on what he needs to do in that particular situation, super assesses the situation and figures it out. It's better than the freezing, which I do. What do? I don't know. What if I do the wrong thing? Can we just drag him outside of class and pretend we didn't see it? Anyway, so... And my son was impressed. I broke up a fight at Steel Canyon. My daughter was there for a volleyball game, and I'm walking across the parking lot, and some poor girl gets jumped from behind by this other girl. And we're walking around the parking lot, and the security guard's very overweight and sitting on park bench very far away. So I just run over and go, hey, knock it off! And I break up the fight. My son's looking at me going, wow, I've never actually seen you be adult before. Thanks. And I worked at a high school. I know how to break up a fight. So when you yell, who do you grab? No, you don't grab both. You can't hold both. No, you grab whoever looks at you needs help. If neither of them look at you, do not get in their way. I'm serious. One of the biology instructors at Ron Benyaga got his shoulder dislocated by trying to break up a fight, by jumping in the middle, going, stop it! Because if neither of them look at you, they don't want to stop the fight. But if one of them looks at you, means help. Grab the other one. What if you grab just randomly one? No, the other person says, thanks. Not good. Okay, you don't, yeah. Or Mr. Kegrice at Ramona High School, he broke up a fight and the kid kneed him in the nuts, basically, for trying to break up the fight. Kegrice happens to hold the world record for deadlift for his height, and so for his weight. And so Kegrice grabbed the kid by the head and went, and just smushed him into the sidewalk and broke his cheekbone. And probably didn't even flinch because he's probably used enough testosterone in his life. All right, so now, but don't kick anybody in the nuts. Okay, so having this pre-programmed motor program, you're learning, your little wheelie suitcase, the sensation of perception comes in and triggers these motor programs to be produced. Some of these motor programs are thoughts. Some of these behaviors are thoughts. What are anybody have any good repetitive thoughts that keep sneaking into their head? Songs. Yeah, songs will get stuck in your head. Something triggers it, and all of a sudden you start singing a song. Baby shark, doo 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 doo. pen, pineapple, apple, pen. Okay, but these stupid little songs. I was just gonna go the state. Wait, like a good neighbor, State Farm is there. Okay, those little stupid jingles, those songs that pop into your head. Those are motor programs. And do they, especially with music, they come and go, with as things go. But what about? I always get paranoid thoughts. They're my favorite. It's my sign if I've had too much caffeine. And I start going, oh crap, what if? And I just go down the what if trains. Yay! And then you kind of say to yourself, why am I thinking this? This is not good. But why do those get triggered? Because you're anxious. And when you're anxious about something, your brain goes into the same repetitive thoughts. We look at, you can go to the far end of things like anorexia. In anorexia, the person has tremendous anxiety about eating. And the more nervous they feel about eating, the less they feel hungry. And the more nervous they feel about eating, and it just becomes a vicious circle. And so people say, well, why can't you just eat? Well, it's like, why can't you just go pet the tiger at the zoo? You want to, but you can't. The anxiety is just so high that it debilitates the ability to function. And it's one of those things where the brain, the sensation and perception triggers the thought process. So how can I measure that? How could the Cognitive School of Psychology measure priming? How do we just measure priming? Scales, yeah. Scales. Well, we use Behavioral School of Psychology, which you'll find out that the only way to measure anything in psychology is the Behavioral School of Psychology. But we use scales. We use ratings. Experiments. Cognitive School of Psychology is really big about priming. We look at what you're paying attention to. We look at how you're paying attention. Okay, and so we also look at your memory. That's the Cognitive School of Psychology. The problem with the Cognitive School of Psychology, it doesn't exist. Why do everybody love it so much? People love string theory. It's a theory. Because we don't know exactly what you're thinking. We can see what your brain is doing, but we don't know, just because we can see what his brain is doing, we don't know exactly what he's thinking. Because this is subjective. Yeah. Okay, so a lie detector test, there's two different kinds that are floating around right now. One is the MRI one, the brain scanning one, that uses something like the EEG and the MRI. The other one is what's called the polygraph test. Okay, so what was that? There was a TV show, game show about lie detector test. No, does Maury Povich have one? There was one of those stupid TV show game shows on with a lie detector test, and they had people set up and ask questions, and then they had their friends and family say what the correct answer they think they would be, and then they had the person answer the questions, and it was pretty brutal. So the way they used a polygraph. The way a polygraph works is it measures your muscles moving in your body. It measures your eyes moving, it measures your teeth clenching, and it measures your temperature, your body sweating. Okay? So any good psychotic can control their body perfectly. But what do most people who aren't psychotic? They're all over the place. We saw him just moving around a little bit, and his brain's all over the place. But if you're really good, it's not psychotic, it's psychopathy. It's someone who has antisocial personality disorder. They can really control their physiology really well. Did you kill the person? No. What's your name? Santa Claus. But yeah, that's cool, but yikes. Anyway, probably the reason that they're psychotic is because they're so controlled. Moving on. What, E16, what is that? My wife's watching Scandal. God, I hate that show. Every time I walk by, someone's being tortured. Like, will you? But it's good. He's talking about cutting toes off and which toe he likes to cut off. Okay. That was yesterday, whatever season my poor wife was in. Okay. It's still better than what's going on now. Not important. Now, so if I'm measuring all these things about you, can you fake all of those? Some people, but very few people can. Most people can't. So lie detectors work for most people. But it turns out that if you just stare into someone's eyes, what is that movie, Meet the Parents? Is it Meet the Parents? With Robert De Niro and, well, he holds his wrist and looks at him.
Yeah.
Yeah, you can know if someone's lying if you're just smart and know the person well. Patricia Santana, who just retired, a Spanish instructor, she's wonderful. She could easily tell if a student was lying just because she's a good mom. She looks, you're lying. Because she just knows people really well. She just has that sixth sense. Okay. Okay, so the polygraph test is really hard to fake. But the hard thing is do you know if the person's nervous or lying? You don't know. So the results are very hard to figure out. It's not that people are trying to fool it, but someone could say the correct answer and it shows you're lying. It's because you're afraid of getting caught or just nervous of the situation or feeling. So it's called noisy data. It's very, very crappy. Anybody watch the Mythbusters, the lie detector show? Yeah. And so they did the brain scanning one. And to try to fool the brain scanning one. And all one of the guys had to do was think of dirty thoughts about one of his co-hosts, and he fooled the brain scanning. Literally, he was in his head with the co-host, and yeah. Because he told him afterwards. They don't hide much on that show. Okay. Did Grant and her ever get married? Because I know she was pregnant in one of the later episodes. I think so, yeah. Okay, moving on. So, it was before they were dating, though, and it's just funny. So we don't really know exactly what you're thinking, but I can measure your behavior. That's why the behavioral school is so easy, because if I prime you to think something, we call that classical conditioning. It's classical conditioning. Super easy. All I have to do is present a stimulus and watch your behavior. Yeah, well, people and dogs are the same behavior. We have, our Umwelt is much different than a dog's Umwelt. Our sensation and perception is much different. Because this is one of the educational psych person was arguing with me about. He goes, well, once somebody learns the paradigm, the test doesn't work anymore. And as soon as you learn that you're being conditioned, it doesn't work anymore. And that's a problem with humans because our sensation and perception, bless you, is not just now, like a dog's is. It's also what's going to happen next, and it's also what's happened in the past, and it's also what someone else is thinking. So much easier to be a dog. Okay? I wish I had the life of our dog. She's looking at me like, I need to go to the groomer. And she's all matted. And when she gets home from the groomer, she's all happy. And the matted and more nasty she gets, the more grouchy she gets. She goes to the groomer and gets all fluffy. And she's like, yay, I'm a happy, fluffy dog. I can see her in front of the mirror going, why don't they do something about this? Look at my hair. Okay. This whole idea of classical conditioning works really, really well for animals. It's very complicated for people. It's very complicated because of all this cognitive crap that it's not real, but do you think it really exists? In our mind, it exists, and therefore we are studying the mind, so we have to talk about it. The problem with psychology. If we stayed with the brain and behavior, cognitive neuroscience, or behavioral neuroscience, we'd be set. But the cognitive crowd jumps in and has problems. Okay, so why do you think evolutionary psych is up here. Why is this important for priming? Right? So what is the basic principles of evolution? Yeah. Evolutionary psych talks about the fact that humans form concepts. Well, we'll talk a lot more about concepts next week, but concepts are not data. They're not observations. What are they? Well, thoughts would be one way of saying it. Ideas is another way of saying it. A hypothesis? Did we say that? Yeah, hypotheses. So we come up with these concepts. We try to parameterize things in our brains. We just naturally try to parameterize things. People try to form concepts. And when people try to form concepts, they cut out the details and get the big picture and get the idea, and that's right hemisphere. Our right hemisphere is evolved to just look at the big picture. How does this whole thing fit together? Why is that important for us? Where is the end result for humans? The end result is death. That's very nice. Very dark. No, think about what is the end result of forming a concept? Not necessarily, it's satisfying when you prove your concepts. Humans think in the future. We take information from now, we find some sort of cause and effect relationship, form a concept, and then apply it later on. So what I'm really brainwashing you for the first week of this class is to think scientifically about everything. You become very annoying to everybody. Because why do most people not think scientifically? It's hard and takes time. And there's too many what ifs, and you realize that we can't do anything. Yeah. The idea of forming a concept is that once you have, this is the analogy that I thought of while skiing. I was trying to learn how to turn. I figured out turning pretty well, but my turns are not fluent, and my turns were not, elegant, and I couldn't turn when I was going really fast, which is dangerous because when you're going really fast, turning is kind of more important. And so I didn't have the right concept. If you have one data point of observation, one data point, can you draw a conclusion from that data point? Oh, you can. But can it go anywhere? Well, you could conclude that, you can conclude this, you can conclude that. It doesn't really matter. If you have one data point, you have infinite number of conclusions that you can make. Right? But what if I have two data points? What happens with my conclusion? It narrows significantly. But is that the truth with two data points? No, because then if I have a third data point, no, how do I figure this out? What's my conclusion? You average, well, not a triangle, but you average those two dots and go through your observation. What if I had another data point? It moves or skews my conclusion. Every time I add a data point, it subtly changes the direction of my conclusion. Well, what's interesting is this is actually called a scatter plot, what I'm drawing. Okay? And the scatter plot, there's something that if I keep collecting data, and the data is all lining up like this, what happens with my conclusion? It becomes, if I add another data point, does it really change my conclusion very much? No, because the more data points that I have, the easier it is to
to really understand your concept. And then you start looking at a data point like here and go, does that fit my conclusion? No. That doesn't fit my hypothesis, but maybe it fits this hypothesis. Maybe that data point means something different. And what's interesting is when you're, anybody know what this is called, by the way? I know this is called a regression. Well, this could be an outlier, or this could be a maybe there's another conclusion that is involved with something with a new data point. So if you think of these as people, each one of these as a single person, and you want to draw a conclusion about people, you want to classify, organize people by type. We'll do this during the semester with personality type. When you get your we'll do personality testing here, we'll get your personality profile, you'll interact with other people with similar personalities to find out how close your dots line up. Anybody know what the actual dots look like in a personality profile? They're a big mass, big circle. So can you draw a conclusion from a circle? No, because that's the same as that, which is the same as that, which is the same as that. You got nothing. It's as good as one data point. Okay, but the idea of forming a concept, the concept is based on the number of data points that you have. Let's go back though to if you have good well, I'll just I went to the truck show in my head. I like building bicycles, and I really enjoy. I got one to work on right now, which I really need to spend time working on it, but you guys keep getting in the way. I have to do that work thing before I can play. But I have, no matter what's wrong with a bicycle, can I fix it? Yes, the older it is, the easier it is for me to fix, because I've worked on old bicycles a lot more than the modern stuff. Modern stuff, you have to buy new tools, and it's stupid. I don't own any modern. I have one modern bicycle, and I take it to the Trek store because I'm not going to fix it. But if anything goes wrong, because I've had so many data points on a bicycle, I can fix anything. It doesn't matter. And even though I'm taking apart the forks right now on my old bike I bought off of Craigslist, $30. Oh yeah. All the inside parts of the suspension have turned into yellow or red paste, and they're slowly dripping out the bottom of the leg. Yeah, it's really awful. Just super sticky, nasty, cancer-causing. Anyway, but did I take them apart, clean them out? Ordered the elastomers on Amazon. Haven't had a chance to put them back together yet. But I will. Whole $9 to fix the fork. Oh yeah. Okay. But how come I can fix it, even though it should just be thrown away? My experience and my motivation. So then we get to psychoanalytic. Psychoanalytic is your unconscious. That's why I really like watching Roadkill Garage and Hot Rod TV and all these stupid gearhead stuff, because I love these guys that they especially if you ever watch Roadkill, they basically get an old piece of crap car, tune it up, and then go destroy it. Yeah. And it's meathead stuff and it's stupid, but at the same time it's like they head it off to drive across the desert in a dump truck they converted into a truck to make wheelies, with a big giant drag racer motor on the back of it. Yeah, exactly. Yeah. Unconscious motivation. Motivation. So there's this really interesting thing about the psychodynamic or psychoanalytic school of psychology that talks about your unconscious motivation. This is that stuff at the bottom of your wheelie suitcase. And with the psychoanalytic, this unconscious motivation, that I like solving problems. I like being challenged by solving problems. That's why I like those shows. But part of that comes from when I grew up, we didn't have very much money. My mom was a teacher, and she didn't make very much money, and my dad left to go to California, did not send alimony back to my mom, and so we didn't have a lot growing up. Awkward. Okay?
And because we didn't have a lot growing up, why do I like figuring things out? I did have a lot of time because the nearest kid lived like 5 miles away, and in the wintertime, it's way too far to trudge. Yeah. Because I don't like spending money now because of my childhood experiences of not spending money. I just laugh when like someone goes buys a really expensive car. I'm like, wow, how do you have the money for that? I don't understand. I don't get it. But we can afford my van. It's paid off in 2 months. Yes. 95,000 miles. 96 now after the road trip. Anyway. But I'll have no car payment for like 2 months. Then I get my daughter a car. And she won't want a roadkill car. She wants a little Nissan Rogue. It's safe. I'll drive it when she goes to college. I'll drive a girl car again. Oh well, I got my mom van. I can drive a girl car. Okay. No pride. So, or lots of pride, depending on how you look at it. So, I love my Mini Cooper. The guy that sold it to me goes, you're the first straight guy I've ever sold one of these to. Shut up. 40-year-old women or gay men buy Mini Coopers, and I like driving a Mini Cooper, and my gay neighbor bought one. Dude, you're not helping me out at all. I love that car. Okay, so the idea of unconscious motivation, can we test this? Well, believe it or not, I'm going to write the word. Triggers. Believe it or not, people have triggers. These triggers are either caused from post-traumatic stress disorder, those are very serious triggers, but other people have triggers, like relationship triggers. If you've had a bad relationship with your parents, guess what happens when you start getting into relationships in your own relationships? That they trigger anxiety. Oh, I don't know if I should date this person. Why? They're wonderful. Where'd that come from? I don't know. Stop it, Dad. I mean, Mr. Weiner. What'd you call me, Dad? I did not call you Dad. Okay, that's... And Freud, so let's talk about this. And then we stroked the goatee and you sit on the couch. But you hear lots of these things, these little triggers show up. These little triggers are things that are unconsciously motivating and changing your behavior that you're not aware of. Then our world is full, according to Freud, of these primes, of these triggers that are constantly poking at you, telling you to do things and telling you to avoid things. And it's cool, but at the same time, it's still really just behavioral classical conditioning. The problem is you need to be conscious of the things that you're conditioned to. No, there's actually, we did this experiment many times. So I had a student, or all my students, take cotton balls, okay? And if you're cotton phobic, you don't have to do this. You put it in your mouth for 30 seconds. After 30 seconds, you take it out and you put it into a Ziploc bag provided. All the Ziploc bags and all the cotton balls were weighed prior to so we had a tub of Ziploc bags that are weighed dry, okay? Then we hand the Ziploc bag to the student, and then we have them put the cotton ball in their mouth for 30 seconds, and then take it out, zip it closed, and then we weighed the tub again. So what did we measure? The amount of spit in the average college student mouth for 30 seconds. Yes, not during flu season. Okay, then I had the second tub of Ziploc bags. We handed them out. And one or two students were like freaking out because that squeaky feeling of cotton was causing them to completely go nuts. We did not allow them to continue. They were asked to sit out. Okay, because when you get nervous, what happens to your spit? It goes away, it dries up. And then the cotton ball sticks to your tongue, and then you gag, and then you panic attack. No, didn't happen. So then, as the students, right when they put it in their mouth, I took an entire bag of Sour Patch gummies and went, oh, in my mouth in front of the class. Oh, just the whole bag. And I stood there. And while they were sitting with a cotton ball in their mouth, and then after 30 seconds up, we took the cotton ball out, put it in the Ziploc bag, and guess what happened to the spit? There was more spit in my class after eating a patch of me eating a patch of gummy bears compared to them eating a patch of gummy bears. Now, it was interesting, one student was an outlier. She did not increase her spit at all. Why? She's never had them. Well, she happened to be Japanese. and it's never had a Sour Patch Gummy. She's had sour candy before, but the word Sour Patch Gummy didn't mean anything to her consciousness. But as soon as I let her smell the ones in the package that I haven't left, what happened? We call it gleeking, when your spit just comes flying out of your mouth for no good reason. She went, oh! And it's so, because she didn't understand, didn't have the latent vision, did she get conditioned? No, but was she still conditioned to sour? Yes, but she didn't know. She didn't get it. So these primes, these primes that we talk about are so important. And the reason they're so important is because this is a lot of what psychology is. It's looking for these primes, looking for these triggers. Do certain things make you pay attention? Yes. How does something make you pay attention? It triggers the unconscious motivation to try to figure things out. My son and I are having a race to who can solve the Rubik's Cube first without watching YouTube. Neither of us can do it. I've been playing with it since the 80s, so that's not important. But it's one of those that we've gotten really close a couple times. And he'll find my cube they're in the car. So I remember sitting at a stoplight and not going. I'm not on my phone, I'm on my cube. But only a few times. So, but if I get really close, what does he do? He messes it up. I was like 4 pieces away, like 4 moves away from finishing it, and he saw me almost done. He goes, "Ooh, let me see it." I go, "Here, look, I'm almost done." He goes, "I hear." He goes, but is learning to figure out a cube a prime? Think about it. No, you'll learn in psychology. There's no really good answer. Yes and no sometimes. Maybe, sure. A little bit of both. Yes. So is figuring out the cube a prime? I always like I like to try and solve problems. I really like that. So that concept is there. And so I love puzzles, I love that kind of stuff because I like doing that. I like playing with a computer that I don't know how to use. No, it's just fun for me. Other people get really frustrated with it. I'm like, I'll figure it out. Okay? But that's part of the concept that helped me lead my future behavior and part of my unconscious motivation possibly that helps me maintain going forward. But can anybody solve Rubik's Cube in here? Okay, so if you all can solve one, how do you know how to solve it? It's a pattern. Once you see where the pieces are to start with, you follow the pattern. And once you follow the pattern, this is the problem with my attention span, is I do really well following the pattern for a period of time. Someone asks me a question, what? I look back, where was I? Damn it. Okay, that's my biggest problem so far. But once you figure out the pattern, does it require more or less consciousness to solve it? Less consciousness to solve it. So in other words, your motor program organizes a series of moves, and once it organizes a series of moves, do you have to think about it anymore? No, I had student Drake 2 semesters ago. Drake could get under the desk. Just pick it up, Cassidy sitting next to him, put it on the desk in front of her. She'd mess it up, hand it to him, under the desk without looking, hand it back to her. He had one that was, all sides had different shapes on them. It's like when you turn it, like yeah. He could do that one under the desk. Because is it the same pattern as the other ones? Yeah, it's the same moving the things around in the same pattern. So once he figured it out, he could do any sort of Rubik's Cube really fast because he got it. He understood the concept. The concept activated a series of organized motor programs. Organized motor programs produce very smooth behavior. Fluency. I'm never probably going to get there with the cube, but whatever. See, I hit Control M before, and it added a new slide at the beginning of class today. I hit Control M now, and it's not. No, Control N's a new spreadsheet. Insert slide. Fine. Wow. How do you feed your unconscious?
Once you're aware of like what
I'm going to a Friends episode. You're a strong, competent woman. You don't need to smoke. And Chandler, okay, sorry. I'm so happy young generations are watching that show again on Netflix because now I can make stupid Friends references. I saw it that time. I was, yeah. You're a wonderful machine, Windows. Thank you, Cortina. Stupid. Okay, it'll come on in a few minutes going, you're welcome. I think Cortina's been drinking. Okay, so, yeah. I've never been able to solve it in my entire history of my brother being able to solve it in 40 seconds. And so maybe my brother was in the Vermont State Championship for Rubik's Cube solving in the 80s. And he did really well. He actually had his Rubik's Cube sanded so that it would turn faster. You take them apart and sand the edges a little bit, add a little graphite to the center so that it would turn faster. He was like ninja skill. And what's funny is that he can still solve one no problem. Like if I throw my Rubik's Cube in the mail and send it to him, he'll send it back solved because he's funny that way. Maybe it's a competition with him, but I've never been able to solve it. And I bet if I watched the YouTube video once or twice, I probably could solve it because everybody that I know that can solve it has watched the YouTube. Did you figure it out by yourself?
Yeah, I've been doing it for a long time.
Awesome.
We used to have like me and my friends have competitions.
Oh, that's awesome. Yeah, I want to be that guy. I want to figure it out for myself. Anyway, so the idea of what I was going for with the prime and the Rubik's Cube is that once you see where the pieces are, does it activate a different motor program? Yeah, it activates a different motor program, and your sensation and perception of coming in to solve it, you can't solve it without looking at it first. If you give someone a messed up Rubik's Cube blindfolded who don't know what the colors look like, they can't solve it. But as soon as they look at it once, can they be blindfolded and solve it? Yeah, there's some guy on YouTube that set the record for the 2 Rubik's Cubes blindfolded. So he looked at both of them, put them down, put on the blindfold, go. And then he solved both of them in 8, I forget how many seconds, 8 seconds at least. Get away. Okay, of course I'm the one with my jumping over the picnic table with my bicycle. So I should get away. So I want to go through real quick about how a single neuron works before we send you off over the weekend. What do you have to watch over the weekend? Bunch of TED Talks, okay? I'm not looking for any written analysis or anything else. I just want you to watch them, okay? And you will see in some of these videos, they will talk about priming. They will talk about the false belief test and the theory of mind. They will also talk about with the dog in the MRI, which I love, and the scientist who sticks her baby in the MRI, which I love. It's that we want to show how people, the neuroscientists, are trying to figure out what our thoughts are by looking at the brain. How do we know if a dog loves you or not? Well, but cats pretend to love you when it's food time. Well, we can't look at their electrical activity in their brain, but if we actually look at fMRIs, physical structures of their brains, then we can see the areas that light up when they're in love or rewarded by something, and then you'll see. Okay, it's a lot of it's connecting dots. And if you get enough dots, can you draw a conclusion? Yes, and the more dots you collect, the stronger and more consistent the conclusion is until you start noticing the dots changing. then maybe if the dots change, wow, maybe I came with the wrong conclusion. Okay, so a single neuron, one neuron. I'm going to draw one neuron. If my friend JR was here, he'd call this Ned. Ned the neuron, but I don't like that. I think it's stupid. He always says it Ned like that, but I don't. Okay, so a single neuron has up to 10,000 branches. There are some neurons called Purkinje fibers, which I will show you in a video next class, and they have tremendous amounts of branches that stick out everywhere. Amongst these, well, I'll draw the second neuron in a different color here in a second. The middle part where the branches stick off is the cell body. In the cell body is your badly drawn DNA. So in the cell, why is the cell body important? Well, the information. So if you damage the cell body, you'd kill the whole neuron. But if I damage some branches, guess what they do? They regrow. Okay? This part that sticks off the bottom is called the axon. The axon is electrical. It's an electrical wire. Fill in two classes in my physio class later, and you'll understand that it produces electrical current. You can just say it's electrical. It's covered with fat. When you cut a steak, what color is fat? Right. Yeah, it's called myelin. Myelin is basically fat. Why would you put the fat on the axon? Electrical. It's insulation. The same reason we coat the wires up on the computer with plastic, these wires are all coated with plastic, increases the rate of electrical connectivity. All the power lines in our neighborhood are coated with plastic, okay, because they don't want to lose electricity going from house to house to house. Or cooking people, one of the two. Okay, so at the end of it, this is called an end bulb. This is neurotransmitters. The end bulb releases neurotransmitters. Neurotransmitters are chemicals. So, a single neuron is an electrochemical generator. It uses a tremendous amount of this. What is this? Energy. 20% of your body's oxygen is used just to keep the ATP going. If anybody's ever gotten hypoxic before, low oxygen level, it's really fun. You should try it. You can look down, your fingernails turn blue, and then you can't think. It's cool. My son, when he was little, had the croup, and we went to the doctors and they did the blood saturation level. He was at 86 or something. And they immediately panicked and ran him into the hospital. We're like, he seems fine. But why is it important to keep your blood oxygen saturation level up to 98% or 100%? Yeah, you can start having seizures if you go down below 80%. Because your brain needs the oxygen to produce ATP to keep the neurons firing. When the neurons stop firing, well, this is a little bit more complicated, but most of the neurons work by stopping each other. Most of the neurons work by stopping each other. So what if I stop stopping? They go too much, and if they go too much, it causes a seizure. So, but if I stop too much, you die because you cease. Like alcohol stops neurons. Blacking out stops the neurons from forming memories. Passing out blocks the consciousness element, and then stopping breathing. Alcohol poisoning is stopping the lower parts of your brain that actually keep you breathing. Those are pretty hard. You have to have a lot of alcohol very quickly to stop breathing, but most people who die from alcohol poisoning aren't necessarily choking on their vomit. It's that they actually stop breathing. It's called shallow respiration. So it looks like they're breathing, but they're not choking. It's they're actually not taking a deep breath, and as their CO2 levels go up, then they start coughing. So you think, oh, they're throwing up, but they're coughing because their brain's trying to get their CO2 out of their lungs, and eventually, if they don't get help or a respirator, yeah. The synapse is the space. The synapse is a space. And so what I'm going to do is I'm going to draw a second neuron up here. And let's use this lovely pink. Okay? My second neuron is going to come from over here, and I'm going to draw just the axon with its own little end bulb on it. And what does that second neuron do? It sends its message to the branches of a second neuron. Now, all along this path where it's running into these branches, guess what forms? More end bulbs. So as the axon's coming along, and if it runs into a branch, a little end bulb grows right there. And on the branch, this thing called a receptor nodule, grows right there. So wherever this neuron crosses other neurons, they talk to each other. How do they talk? Through neurotransmitters. Neurotransmitters come in 26 basic flavors. Okay? There's 2 primary functions and then 1 complicated function. The 2 primary functions are, hold on, the plus transmitters, which equals go, and the negative transmitters, which are stop. What do they think they go and they stop? Don't say sending signals because we don't know what a signal is. So what do we have so far? The transmitters. So if I release a go chemical on this cell, it's going to release more neurotransmitter. If I put a stop signal on it, it's going to release less neurotransmitter. Again, another week of physio class has just passed. It's a lot more complicated than this, but in this class, we don't need to be that complicated. But what we start to realize is that each cell has its own personality. Each cell has its own amount of transmitters it releases. It can release maybe 2 out of the 26. Each cell can release maybe 1 or 2 different chemicals. They're finding out more now that they release more chemicals, but as far as what the good science is right now, they release maybe 1 or 2 different chemicals. So if this cell is always releasing a stop signal, we call it inhibitory neuron. And so your brain, there's part of your brain called the basal ganglia, which controls the initiation of movement and ballistic movement. Okay? What if we don't have enough stop signals in the initiation of movement part of your brain? You do it. It's called impulse control. I can show you a quick example of what that looks like. I'm not even close to spelling it right, but my computer knows what I'm talking about.
May 15th through June 15th, it's Tourette syndrome.
Cookie, hedgehog biscuit, but it's really exciting to see a different type of biscuit for the first time. Hedgehog biscuit, but anything I've ever known has the potential to become a tick. Biscuit. So, and why certain words stick around is a mystery. Biscuit. So I have no idea. Biscuit. Why biscuit out of everything else? So it's hedgehog and hedgehog too. That's Aladdin. Biscuit.
So she has Tourette's disorder. She has the inability, the stop neurons in the part of her brain that triggers behavior don't work. So what happens? She just moves. Hedgehog, biscuit. Happy birthday. Wait for a happy birthday.
So you've taken ownership of it, obviously, and made it the title of the show. So what is going to be in the show?
Biscuit. So the show is a celebration of spontaneity, disability, biscuit, disability culture, things that you never knew would make you laugh. Biscuit. It's Biscuit, having Tourette's means that I'm neurologically incapable of staying on script. Biscuit,
Anyway, so you get the idea. And for her, it's like when you have to sneeze. Can you control it? Oh, you've been in an elevator and you've been controlled before. You're like, and you can like choke it down, but it requires 100% of mental effort to stop that sneeze. Yes, you can't have a conversation and stop the sneeze. That's what it's like for her. The sneeze is a motor program stimulated by nasal nerves being triggered. And once the sneeze motor program is initiated, it's almost impossible to stop. And it's fun because people are either odd or even sneezers. And if you're an odd sneezer, you always sneeze like 3 or 5 times, or just once. An even sneezer always sneezes twice. And that's the motor program you develop. Can you change your sneeze? Are you even or odd? Are you even or odd? Even, yeah. Yeah, okay. So as I saw you say, I'm like, ah, cool. I'm an odd sneezer. I'll sneeze once or 3 times. But can you change the way your sneeze sounds? Yes, my daughter had the most awful sneeze, like for a long time. And so now she goes, chew, at the end of it. And which, now it's automatic because she's set up a new behavior program. So now when she sneezes, chew, and it's really cute now. But the point of it is that when we start looking at something very basic and very simple as neurons, all they are stop and go signals. How can we there's actually one other called the second messenger system, which can cause lots of different effects on the postsynaptic cell, but we don't know about those. They're fine. But when we look at this, how can this cause all of human behavior? Just stop and go signals. It's a circuit. How many neurons are in the circuit? 86 billion. Each one can talk to 10,000 others. Each one can branch out. And as this axon grows, wherever it comes in contact with a dendrite, the branches, it can grow a new synapse. Do all synapses that you form stay? No, you actually do something called pruning. You trim them away. Because you don't need to remember certain things. The details are often lost, and the big pictures are reinforced. So that's why you think priming is so important in the brain. The brain doesn't want to pay attention to all the details. Biology's lazy. Biology likes a limited amount of resources for the maximum amount of gain. So the brain's not going to remember all the details, it's going to remember the concept. Once it activates the trigger of the concept, the details come back. So the part of your brain that stores memory, called the hippocampus, sits right next to the part that's right behind your cheekbone here, which is where the amygdala, which causes anxiety. So our brains have evolved to pay attention to all the bad things. What happens to the good things? They fade. So it's like if I go to rate my professors and one student who shreds me and lots of people like me, I'll remember that one person shredding me, but not all the people liking me. Why? Because anxiety is very close to memory. Happiness is an activation of future behavior. So I always go out to my bike shed. My bike shed's very full right now. I have 8. And so I'm actually going to get 9 this week. But that's not important. I'll fix one and sell it, and then I'll have money to buy another one. But when I go out to my bike shed, it's happy. I always say hello to all my bicycles. I pet them on the seat or the front wheel, wherever they're all hanging up in my little shed. I'm actually going to get rid of other crap in my shed next week after my kids go back to school, so I can actually leave here and go do stuff that doesn't require them asking me to do stuff. I'm going to take out some furniture. I have a chest of drawers in there that's got all sorts of nuts, bolts, and stuff in it. I'm going to get rid of that chest of drawers so I'll have room for 2 more bicycles. All the stuff's just going to get dumped on the floor, I'm afraid, but that's not important. But why do I get happy when I walk out to the bike shed? Because even though I don't get to ride as much as I really want to, that trigger, that prime, activates a bunch of go signals. Those go signals activate memories from the past and future behavior in the future. When I walk into the garage and it's messy, does it make me anxious? Nope. My wife walking into the garage makes me anxious. Yeah. And why does it make me anxious when she goes into the garage? She's going to tell me to clean. That was yesterday, by the way. The garage was a mess, because actually that was Wednesday, because we got home from the trip on Tuesday. I dumped everything in the garage, didn't put anything away yet. Wednesday, I left in the morning to go to class. You haven't cleaned the garage? No. I sat around all the afternoon, so tired. Anyway, so the garage is clean. But the idea of the stop and go signals, we're not talking about individual neurons anymore. We're talking about patterns of neurons. So individual neurons in the amygdala trigger individual neurons in the hippocampus, which trigger neurons all over your brain to light up. The way that person smelled, the way the person looked, the time you went out with that person, all these things start flooding through your consciousness because they're tied to those particular neurons. Like if you ever have a bad breakup, the person's cologne or perfume, you smell it and your brain goes, mm-hmm. We used to enjoy the smell, but what happened? It immediately triggers all these negative emotions because it's your brain's way of saying, I get the concept this is bad, everything else associated with it is bad. The idea of trying to don't try to understand how the brain works. You take about 3 more psych courses and then try to understand about how the brain works. Because it's so complicated that you can get so stuck in looking at the specific neurotransmitters and the specific things, but we have to look more at the way his brain looks. The big picture of it, looking at it from satellite level, not looking at it from microscopic level. Yeah.
Are the waves like stop and go in the brain?
They always go. The brain waves always, your brain is always firing all the time. What happens if the cells stop firing? We're out of time, but your brain cells die. They need to fire. They need to send electrical signals in order for them to get ATP. In order for them to get ATP, they have to connect to other cells. So when we study fetal alcohol syndrome, parents that drink during pregnancy decrease the firing rates of baby brains. And so the baby brains aren't firing as much, aren't sending as many transmitters. So what does the brain do? The brain cells technically they get suppressed and the baby brain compensates, and then called excitotoxicity. The baby brain has a hangover, and that hangover causes brain damage. Most drugs that moms use, especially like cocaine and those kind of drugs, generally cause lack of appetite, and the lack of nutrition hurts the baby more than the drug hurts the baby. And it's the mom's health that most like hard drugs like cocaine and heroin and amphetamines really cause a lot of health problems. That affects the baby more than the actual substance itself. But it's hard to do that experiment. It's hard to, okay, you eat really healthy and use meth, you don't. And